Hello and welcome in this new video where we will be finally configuring the underlay of a fabric from a lab environment. All the discussions we had in the previous video, they allowed us to identify and understand what are the interfaces that quote-unquote belong to the underlay that we need to create and to configure so that we build a proper underlay. What I mean by a proper underlay is the basis or the foundations on which we will be able to go ahead and configure a working and functional overlay from the perspective of the control plane and the perspective of the data plane. I would like to use the slide that presents the lab environment to remind the key takeaways of the previous recording, like the main roles of each interface. But I will not enter into many details because, again, all those details, we have checked them extensively in the previous video. So if you want more details, I would like to invite you to check the previous recording. So with that said, let's go to the slide. So what you can see on the screen is the lab environment on which we will be working. So it's quite a small fabric that consists into one spine and two leaves. Obviously, each leaf is connected to the spine. As we've seen together, the first interfaces that we will be configuring is the point-to-point between the leaves and the spine. These interfaces will help us build the underlay control plane protocol adjacencies. By the way, when it comes to the underlay control plane protocol, what we will be using is OSPF. And we need to give a name for our OSPF process, so we will be naming it underlay so that it makes sense. Okay, so first thing, we will be configuring these point-to-point interfaces. And as I was mentioning also in the previous video, it's a good practice to reserve some ranges of addresses so that we are able to pick subnets or individual IP addresses from those ranges to make our configurations. And also, when you have the opportunity to do so, which is not even always possible, of course, but when you have the opportunity, it's nice to find a way to reflect in the range of IP addresses the kind of interface that the range is serving. For example, when it comes to the subnet from which we will be picking our other subnets for the point-to-points, I'm reflecting the fact that it is a point-to-point range by putting a 2 in this digit. So actually, we will be playing on this digit to reflect the kind of interface on which the IP address or the subnet will be configured. So long story short, we will be using the 10.1.12.0/24 for the point-to-points, and I will simply take the two first /31s in order to configure our point-to-point interfaces. So here I have the 0/31 and here the 2/31. Now we have the second type of interfaces, which is the loopback zeros interfaces. So the loopback zeros, main use cases, again, quick recap, they will serve as a router ID for our different processes like OSPF and BGP. And also all the overlay control planes, adjacencies and communications will be using this IP address, so the IP address of the loopback zero interfaces. What I mean by this is the build-up of the BGP session, the source and destination of the packets that will serve for the build-up is the loopback zeros IP addresses, and also for all the BGP exchanges, the updates, the notifications, the keep alive, etc. Everything will use the loopback zero interfaces for the exchanges. And I'm also reflecting the fact that it is loopback zero interface by playing on the same digits. So here, as you can see, it is a 0. So it means that this range serves for loopback 0. So I will be using the 10.1.10.0/24. I will take the first /32 for the leaf 1. So it is a .1. The .2 will be used for leaf 2, and the dot 3, I will use it for the spine. Now comes the third type of interface, which is the Loopback 1 interfaces. The Loopback 1 interfaces are the ones that designate the VTEPs that are host on each leaf. Obviously, we mentioned it multiple times, The spine do not have a VTEP. So the VTEPs, they live only on the leaves. It means that each leaf will have a Loopback 1, and the spine, obviously, it will not have a Loopback 1. Again, same story. I will use these digits to reflect the fact that this is a Loopback 1. So this digit will be set to 1. And I will use the dot 1 for the leaf 1 and the dot 2 for the leaf 2. And as a reminder of where we find these Loopback 1s, we find them into the BGP updates in the next hop field. So when a VTEP sends a BGP update to announce the reachability of a host that is attached to it, the next hop field will be populated using the Loopback 1 interface of that VTEP. And also, so this is from the perspective of the control plane of the overlay. And when it comes to the data plane of the overlay, the Loopback 1s are used to populate the external IP header of the VXLAN encapsulated packet. So it is the Loopback 1s that are put in the source and destinations of the encapsulated VXLAN packets. So we already have defined 3 types of interfaces with their ranges: the point-to-point, the Loopback zeros, and the Loopback 1s. Something important that we have discussed together in the previous recording is that if we want to use ingress replication for the transport of the BUM across the fabric, then we are already done for this topic of what are the interfaces that we need. We do not need more than those 3 kinds of interfaces. It's already enough. Again, if you want more details, I would kindly invite you to check the previous video. But if you want to go for the other solution when it comes to the BUM transportation, which is the Underlay multicast, then in that case, we need an additional interface that is the interface of the rendezvous point. So in our case, for our lab, the solution that we will use for the BUM transport is the Underlay multicast. And for that, we will be needing a rendezvous point. Now, obviously, we have just one spine, so we will have just one rendezvous point. In a typical production environment, we will have obviously more than 2 spines. So the 2 spines, we will configure them as a rendezvous point. Also, another point that we discussed is that we have 2 flavors for the configuration of PIM. We can either go for Anycast RP, or we can go for bidirectional PIM, so named as PIM bidir. In one case or the other, we need a rendezvous point because all these are flavors of PIM sparse mode, and we always need a rendezvous point for PIM sparse mode. So even if we decided to go for bidir, we would have needed a loopback address to represent the rendezvous point. So to come back to our addressing plan, we would need the rendezvous point IP address, and I will use the 10.1.254.1/32. When it comes to the naming or the numbering of the loopback, it would be the loopback 254. This will be configured only on the spine, and all the devices of the fabric need to point to this IP address for the rendezvous point. So that's it for what we will be configuring and the key roles of each interface. Now I will just move very quickly to the last slide of this recording, which is pretty much the same slide that we just covered, but it will allow me to write the main steps that we will be following into our lab environment. So first, we will configure the point-to-points. Then we will configure the loopback zeros. Then we configure the OSPF process. Obviously, we will announce the loopback zeros and enable the process OSPF on the point-to-points. Then, as a fourth step, we will configure the loopback ones. And finally, we will configure PIM. And I would like to add even a bonus task, which is starting the configuration of the overlay control plane and the overlay data plane. Of course, we will not push very far this section, because to populate it properly, we would need many additional details and information that we did not check so far. But from the perspective of the very basic entries and the main entries that we need for the overlay control plane and data plane, we have already spoken about them, so I would like to introduce them at the end of this section as a kind of bonus. But when it comes to the underlay, really, it stops there. The bonus, it is steps for the overlay. So now let me go ahead and share my screen on the secure CRT so that we can proceed with the pushing the CLI. So welcome back on my screen share. Here, as you can see, I have opened a secure CRT on our 3 devices from our fabric. So I have simply 1 tab per device. And to know on which device I am, I would invite you to check the name of the tab. So the first tab is for leaf 1, the second tab is for leaf 2, and you guessed it, the third tab is for spine 1. First things first, let's double check that we do not have any relevant configuration on the device. Obviously, we will see that we have the default configs that come with any Nexus 9K, and we have the management configured, otherwise you would not be able to SSH to the device. But other than that, the physical interfaces, they are all empty. We do not have any feature that is enabled. Yeah, so that it's very clean or empty. Let's do the check for the other 2 devices. So it's the same for the leaf 2. And hopefully it will be the same for the spine 1. Great, so we have nothing. So let's start the configuration of our point-to-point interfaces. By the way, you will see me checking the other screen because I have there the interfaces and the IP addresses. So the interface that connects leaf 1 to the spine, it is the 1/54. So let's configure the MTU because it's a best practice. I mean, we need to configure the MTU in production, but it's best practice to have it also configure it into the lab environment so that we don't forget it into the production environments. So the MTU, then we add the IP address, which is 10.1.12.1/31. That's it. We go to the second device. It is also 1/54. MTU 9K, a bit more than 9K. And then the IP address 10.1.12.3. Then we go to the spine and we do the same. Here we have 2 interfaces to configure, this 1/50. (10.1.12.0) and 1/51. 1/51, the MTU and the IP address 10.1.12.2/31. Just to be on the safe side, let's ping the other sides of the point-to-points from the spine. So we will ping the leaf 1, which is 10.1.12.1. It pings, and the leaf 2, it is 10.1.12.3. And it doesn't ping. It means probably that I did a misconfiguration somewhere. 10.1.10.12.3. okay? The protocol is down. Okay, let me check here if the interface is shut. Okay, this interface is shut. Okay, now it's up, and now we should ping. Good. So with this, we have completed the first step, which is to configure the point-to-point interfaces between the leaves and the spines. Now we can go to the step further, which is to configure the Loopback 0 interfaces on each of our 3 devices. So let's go ahead. On leaf 1, the IP address is 10.1.1/32. On the side 2, sorry, leaf 2, IP address 10.1.10.2/32. And on the spine 10.1.10.3/32. So the Loopback 0 interfaces are configured. Now we can go ahead and configure the OSPF process. So the first thing that we need is to enable the feature OSPF everywhere. So for this, I will be using this small tab below, and I will send the command to all the sessions, feature OSPF. Now that the feature is enabled, I will go into the router OSPF process, and we agreed that the name of the process would be Underlay. Now I can go ahead on each device individually and configure the router ID being the Loopback 0 of that device, obviously. So for the leaf 1, it is 10.1.10.1. For the leaf 2, it is 10.1.10.2. And for the spine 1, it is 10.1.10.3. And now that the process is properly configured, we can go ahead and enable the OSPF process on the interfaces that we configured. So the point-to-point interfaces and the Loopback 0s. So in each device, it will be interface Loopback 0, IP, router OSPF, underlay, and we give the area. Obviously, we have just one area. Let's configure the default one, 0000. And we do the same for the point-to-point interfaces. So on the leaves, it was 1/54. We enable the OSPF process. We don't forget to configure the Ethernet interfaces between the leaves and the spines as point-to-point from the perspective of the OSPF, so that OSPF understands that those interfaces, he should not consider them as broadcast and go ahead for the elections of the DR, BDR, and all this stuff. Physically, it's a point-to-point, so we are just informing OSPF that, hey, you know what? This is not a classic broadcast network with plenty of hosts connected to it. This is really basic point-to-point interfaces between 2 devices. So IP OSPF network point-to-point. It is exactly the same configuration that we will be copying on the second leaf because it's the same interface. So let me do show CLI history and formatted and copy paste the last block. The show CLI history and formatted is nice to retrieve the latest configurations that we pushed. And as you can see, we do not have all the prompts and so on. So we can simply copy paste the block. So this is exactly the configuration that we want to push on the leaf 2. So we go ahead and push it. And for the spine 1, it's almost the same, but it's different interfaces, obviously. So we do this on the 1/50 and 1/51. Now, hopefully, if we did not make any typo, we should have the 2 OSPF peerings being full I mean, it means that the full state, it means that they are up, running, and perfectly operational. And we should have the 3 loopbacks that are injected, the 3 loopback zeros that are injected into the routing process. So let's check out. Here I am on the spine. So indeed, it sees the 2 neighbors and the state is full. So this is exactly what we expect. Now from the spine, let me ping the 2 other loopback zeros from the local loopback 0. It pings, and for the other one, it pings also. Now let's ping the leaf 2 from leaf 1. Sorry. Okay. So it pings. So that's great. It means now that we have a process OSPF that is working properly, and the interfaces that we configured so far are properly enabled for it. Now we can move to the next step, which is configure the loopbacks 1 on the leaves. So let's start with leaf 1. IP address, it is 10.1.11.1/32. And while we are here, let's enable it for OSPF. We do the same on the second leaf. So we have this time 10.1.11.2/32. And did I miss the command? Okay, it's here. We enable it for OSPF. Now, same kind of basic check. Let's validate that we can ping the loopback 1 of leaf 2 from the loopback 1 of leaf 1. And the ping works. So that's great. It means that now we can move to the last step of the configuration of the underlay, which is configuring PIM. First things first, we need to enable the PIM feature on all our 3 devices. So let's do this. Now there is a second line that we need to push on all the devices of our fabric in order to configure the IP address of the rendezvous point. What I mean by this is that we need to make all the devices aware of the Anycast IP address that will serve as a rendezvous point for all the multicast groups. The way we do this is through a very simple command line, which is IPPIM RP address, and the IP address is 10.1.254.1/32, and then we give the group list, which is 239.110/25. Now, a quick perspective for the group that I have pushed, because you might ask yourself, where do I bring this group from? Because so far we spoke about multicast groups. We spoke about mapping a specific VLAN, meaning a specific VNI to a specific multicast IP address. So far, so good. But we didn't specify the range of IP addresses that will fall into our multicast groups, right? Well, actually, the place where I bring this specific /25 from is from the scalability guides. It revolves around how many groups we can configure across our fabric. This is a very interesting discussion, but it really doesn't fit into this specific recording. I will put it in detail into a future video that I will hopefully make around the multicast, because there are so many details to cover. It's really interesting, but it is really crazy when it comes to the amount of details. So for the moment, please let's agree that we have just, one subnet range that represent all the IP addresses that we will be using as multicast IP addresses. And we are configuring the same Anycast RP for all those multicast groups IPs. So this is exactly what I'm saying here, that the rendezvous point address, it is this IP address for any IP address, any multicast IP address that will be picked from this /25. So this, I push it everywhere. Sorry, the IP address is without a /32. Now that we have pushed this everywhere, we need to do a specific configuration on the rendezvous point. Because for the moment, this IP, it doesn't exist. I need to go on the spine, configure the loopback to 54, and put that IP address on this loopback. So let's do that. I go on the spine, and I configure the loopback to 54 with a proper IP address 10.1.254.1/32. Obviously, I need to announce it into OSPF because it needs to be reachable. And we are almost done for the configuration of the loopback to 54. But for now, what I want to mention is, you know, we said multiple times we are in the context of configuring Anycast RP, so we are using an Anycast IP. So it means that this IP is the Anycast IP of the rendezvous point. In other words, if I had another spine that I would like to configure as a rendezvous point, I would need to go on that spine and push exactly this same configuration block. So if I do a show CLI history and formatted, on the other spine that would serve as rendezvous point, I would put exactly the same configuration with the exactly same IP address. This is why it is called Anycast. It's not something that we configure on the interface by saying, hey, be careful, this is an Anycast IP address. I know it's obvious, but the thing is that there are not many use cases in the network industry where we need to configure Anycast. We use a lot unicast, we are used to broadcast, but for Anycast, that's it. You know, it's just the fact that we configure the same IP address on multiple devices. Now there is an additional element that we need to configure on the spine. We need to tell it that, in fact, he is playing the role of one rendezvous point serving this Anycast IP address. If tomorrow we add additional rendezvous points, then on each one, we need to give the information of the other ones participating into this group of rendezvous points. It will be probably clearer when I show you the command line, which goes on the spine. And it is actually IP, PIM, Anycast RP. And then I give the Anycast IP, so which is 10.1.254.1. And then I give the loopback 0 of our spine, which is 10.1.10.3. So with this line, I'm telling the spine that actually he, meaning 10.1.10.3, it is its own IP address, it's the loopback 0 IP address that is configured on him, is part of the group of rendezvous points that represent this Anycast IP, sorry. It means that if now I go to show IP PIM RP, what I will have is an interesting block here that explains me that the IP address 10.1.254.1 is the RP for all these ranges of groups. But what I'll also see is that the 10.1.10.3 is one of the spines that are configured for this Anycast IP. You see Anycast RP 10.1.254.1 members, and I have only one member, which is obviously my only spine. Again, if tomorrow I add an additional spine, I would need to first, on this specific spine, add another line. For example, let's say that tomorrow I add a spine and the loopback 0 of that spine will be 10.1.10.4. Then I would need to go here and update the configuration by saying, okay, here now I have also the 10.4. And it means that now for show IP PIM RP, I have two members. And I would replicate this exact same configuration block on the second rendezvous point. So I hope that now it makes sense. We are almost done with the configuration of PIM because there is a mandatory step that we must not forget for everything to work. The same as for the IGP's routing protocols, we need to enable PIM on the proper interfaces. So obviously it is on the point-to-point interfaces and the loopback interfaces that are appropriate for the protocol to work. So first let's configure it on the leaves. So we need to configure it on the point-to-point to the spine. It's a simple command. It is just IPPIM sparse mode, and on the loopback one, which represents the VTEP. And we are done. Exactly the same thing on the leaf 2. So let's use again show CLI history and formatted, and copy this. And now for the spine 1, on the physical interfaces 1/50 and 51, sorry, 50, 51, sparse mode, on the loopback 0, and on the loopback 254. Now you might ask yourself, why didn't I enable PIM on the loopback 0 of the leaves? It's because I don't need it. It would not hurt to go ahead and enable it, but technically we do not need it. And again, this is something that I want to cover into the details of Underlay multicast. For now, let's confirm on which interfaces do we have PIM enabled. So show IP PIM interface brief. On the leaves, it is on loopback 1 and the point-to-point. The second leaf, we have the same, loopback 1 and the point-to-point to the spine. On the spine, on the 2 point-to-points, on the loopback 0 and the loopback 254. So with this, we are done. And we can also check the neighborships from PIM perspective. Neighbors. So we see that we have the two neighbors that are built over the 2 point-to-point interfaces. So with this, we are really done from the configuration of the underlay. It works. Now I was mentioning that I want to add a bonus. So it is the first steps for the configuration of the overlay control plane and the overlay data plane. Let's start with the overlay control plane, meaning the peerings for BGP, L2VPN, EVPN. Obviously, the first thing that we need to do is enable the feature BGP. So let's do it for all the devices. We need also to pick up an AS number. So let's pick up the one that is always used into the labs environment, which is 65535. And we configure the router ID. So it is the loopback 0 of each device. We've seen this multiple times. So on the leaf 1, again, it is 10.1.10.1. On the leaf 2, it is 10.1.10.2. And on the spine 1, it is 10.1.10.3. Now we are going to go on leaf 1 and configure the required CLIs so that it can build its BGP, L2VPN, EVPN with the spine. And as we have seen multiple times, the spine will play the role of route reflector. And also we mentioned in the previous video and in the introduction that the IP addresses that we use as destination and source of the BGP session buildup is the loopback 0. It means that when I am on the leaf 1, the neighbor that I will be using is 10.1, 10.3, and again, 0 here means it is the loopback 0 of our spine. I give the AS in which it is, so it's IBGP. I am in the same AS. Let me just try to not make a typo. Okay. And I give the update source. Sorry, just loopback 0. And finally, I need to activate the peering for the proper AFI, SAFI, so address family identifier, sub-address family identifier, which is L2VPN, EVPN. And now we are going to see an interesting thing. Address family L2VPN, EVPN. We see that it doesn't work. It doesn't work simply because there is an additional feature on top of BGP that we need to enable so that we can unlock this configuration line. And the feature is NV overlay EVPN. So again, what the line NV overlay EVPN does is simply allow us to configure the BGP peerings for this additional capability, which is sending all the updates that are related to L2VPN EVPN. So let's go ahead and push it everywhere. Then we go back to our configuration of BGP. So I do show run BGP and I recopy paste the block so that I don't re-enter into it manually. It's just a bit of laziness, you know. And now the address family L2VPN EVPN should be recognized. And we need to configure the send of the community. This is something that we will be touching into the details. Hopefully it will be into the next video, but it's just to say that we need, in the peering, if we have any community, we need to include it into the update, because by default, BGP does not include the communities nor the extended communities into its updates. And here we are really done for the configuration of BGP from the perspective of a leaf. So what we are going to do is copy this configuration block for the leaf 2, because it's symmetrical. All the leaves have similar configurations, right? It makes sense. We are just going to take care of updating the router ID, which is the .2 for the leaf 2. But since all the leaves peer with the same route reflectors, we can have symmetrical configurations. So we passed the config here. And we are done. Now we can go ahead and push the similar configuration on the spine. The only difference is that we need to tell the spines that the leaves are route reflectors clients. So let me pass 2 blocks here and update them. So the router ID is .3. The neighbor, the first one is .1. The second one is .2. Okay, I think I'm done. Router BGP, router ID, the neighbor. Okay. So this goes to the spine. And now I simply need to go inside each neighbor and configure the route reflector. I didn't do it into the block because I never remember exactly the way it is typed. So this is why I wanted to come back into the contextual help. And it is just route dash reflector dash clients. Okay, so let me do the same for the second neighbor. And as you can see, we configure it under the address family L2VPN EVPN. So it means that the spine is playing the role of route reflector for this specific address family. Route reflector client. Okay. So with this, hopefully, if I do a show BGP L2VPN EVPN summary, I should see that my peerings between my leaves and the spine are up. So let's check out if it is the case. Otherwise, it would be interesting to see what we need to t-shoot. Show BGP L2VPN EVPN summary. So the 2 peerings are up. We can see it from the last column, you can see that here for the state, we have a number that is 0. As a quick reminder, this is exactly what we expect to see from a working BGP peering through which we are injecting nothing. It means no host, no network, nothing. If the peering had been broken, we would not have seen 0. We would have seen open send, active, idle, something, because as you know, for the BGP peering to build up, there are multiple stages of a finite state machine. And if everything goes well, which is hopefully the case when we do proper configuration, we should see a 0. Then this number, obviously, it will go bigger once we start doing the proper configuration. In other terms, if we want to see something else than 0, here we would need to do really the real configuration for the underlay in perspective of VRFs, networks, attaching things, etc., injecting things to the fabric. For now, again, there is nothing attached to the fabric. It's completely empty. I really have just these 2 VTEPs at my spine. So long story short, the fact that we have 0 here, it means that the overlay is working and it is ready to send the updates across the fabric. Usually what we forget when we do the configuration is on the spine to put route reflector client. And this, we see it pretty easily when we start attaching hosts to the fabric. We see that leaf 1 sends the updates to the spine, but leaf 2 do not receive them because of the split horizon rule of IBGP. So we clearly understand very quickly that we need to add this command on the spine. But other than that, that's all. Oh yeah, just a last remark on the BGP peerings regarding also production environments. Usually we do not do configuration like I did here. I mean, here I really created 2 different blocks. It means that if I had 10 leaves, I would have basically the same block repeated 10 times. It's not clean. In production environments, we leverage templates or peer groups or something to, make the configuration really shorter and mutualize it. And then we give the proper IP addresses that go into that template, It's the same kind of thing as usual BGP peerings or BGP VPN v4, we try to mutualize so that we have a shorter number of lines and we do not repeat the same block n times for the n leaves that we have. So now that we have configured the basic blocks for the overlay control plane, let's see the basic blocks for the underlay data plane. So it means that here I want to configure the VTEP part of each of each leaf. And as discussed also multiple times, we do not do this by doing something like context VTEP or something like that. We configure a VTEP by configuring its NVE interface, so the Network Virtualization Edge interface. So let's do this. Let's go to the leaf 1 and do, let me go out of here, interface NVE1. It's already yelling at me. Again, usually when the Nexus 9K is yelling at you for a command line, it means that you have forgotten to enable a specific feature. So it means that we need to add something else in the features part for us to be able to unlock this configuration line. And the feature is feature NV overlay. So let's go ahead and configure it. So just let me ensure that I am in conft everywhere because I came out of it at some point. Okay. So now let's go ahead and push the feature NV overlay. It's pushed. Now we can configure the NVE interface on the first leaf. And also, as discussed multiple times, we do not give an IP address under the NVE interface. We provide the IP address indirectly by pointing to the Loopback 1 interface. So source interface Loopback 1. And the same on leaf 2. Source interface and then Loopback 1. Sorry, Loopback 1. And the real final command line that I would like to push into this lab is actually still under the NVE interface configuration. It is a command line that participates in putting the glue between the control plane and the data plane in order to inform the data plane that actually it will not be used as flow down learn, but rather it will rely on BGP to learn the proper host reachability information and so on. So the way we do this is simply by saying host reachability, protocol, and BGP. So we do the same on the leaf 1. And we are really done for our lab configuration. So to wrap up everything, I would suggest that we go on leaf 1 and we do a show run and we just check up, one more time what we pushed. So we enabled the feature that we need, feature OSPF, feature BGP, feature PIM, and we added the first line NV overlay EVPN to configure the control plane in the overlay, so to have access to the L2VPN EVPN command line into the address family section of BGP. And we have enabled feature NV overlay to unlock the configuration for the VXLAN and for the NVE interface. We have configured the rendezvous point as an Anycast IP that is serving all the multicast IP from this range. We have configured our NVE interface that is using as a source the Loopback 1, and the NVE interface, so the VXLAN, is using BGP as a protocol to send and receive the reachability information. We did also the configuration of the physical point-to-point to the spine by enabling, obviously, the OSPF and configuring the proper network type. We have enabled IPPIM's path mode where we need it. We configured Loopback 0 and Loopback 1. The router OSPF with its router ID, the router BGP with its router ID, and the information for the peering with the route reflector. We have exactly symmetry configuration on leaf 2. And for spine 1, it is really same kind of configuration, except that we do not have an NVE interface. We have the loopback 254 that is configured with the IP address of the rendezvous point. And when it comes also to the rendezvous point, we gave a specific configuration line to tell the spine that it is part of a group of rendezvous points that is represented by the Anycast IP 10.1.254.1. And we have also configured an additional line for a spine that doesn't exist to represent the use case of what if you would have an additional rendezvous point later. And yeah, for the configuration of BGP, as mentioned, don't forget to put the route reflector client on the spine to mention that the leaves are the route reflector clients. And we have validated that our peerings are up. From OSPF perspective, they are full. From BGP perspective, they are working. And from PIM perspective, they are also working. So that's really it for the configuration of the underlay and the first blocks of the configuration of the overlay. We are ready to go for the next video, which is on the details and the theory of the RFCs behind BGP, L2VPN, EVPN, and VXLAN. I do thank you for your time going through this video. I sincerely hope that it was useful for you. All the comments are more than welcome. Thanks again, and please take care. Hello. So this is the Iman from the future who is currently doing the edition of the video. While I was editing the video, I was doing additional checks on the small fabric that we configured together. And the checks allowed me to spot 2 mistakes. So I introduced the corrections during the edition on the video. So you have seen 2 pop-ups, but I still wanted to add something at the end of the video just to show you the additional verification checks that I should have done right after the configuration and that I forgot to do, which allowed me to spot these basic mistakes. So the first one is I was doing show IP OSPF route, and I noticed that I am not learning the IP address of the rendezvous point. And the reason why is on the spine, I do not have the proper configuration for the loopback 254, sorry. So here it should not be IP OSPF network point-to-point. I mean, it doesn't hurt anything and it's not even useful since I have /32, but the command that should be here is IP router OSPF underlay and then the area. And I should also have pinged this IP address. It would have been another way to notice this mistake. We pinged the other IP addresses, but this one, indeed, I realized after that we need not ping her. So now the ping works. And the other thing is, if you do a show interface brief, you see that there is one interface that should be up, but it is down. It is the NVE1. And the reason is the NVE1 by default, when we configure it, the system put it as shut down. So we need to manually unshut it. Now, if we do the same command, show interface brief, obviously we see it up. We can also do a show NVE, show interface NVE1, and we see that it is up. So we need to do the same thing on the leaf 2. Interface NVE1 and then no shut. And now the interface obviously is up. Yeah, so with this, we are good to go. See you in the next video. Take care. Goodbye.